Welcome to Prof One YouTube channel. So on this video we're going to talk about short circuit. So well, you've been introduced to series arrangement and the parallel arrangement of resistors on my previous video. I'll put a link at the subscription. So when we talk about short circuit, it's like with current, they don't like stress, so they want they move through resistors, or they move through the circuit where there's least resistance theoretically. So let me brief you more on the short circuit. So with a short circuit, it says what it is. A short circuit is theoretically a zero resistance connection between two nodes. So when you talk about theoretically, it means that theory, but in real life a short circuit has small resistance and it is represented by a straight line between two nodes. So a straight line between two nodes. So this is node 1 and node 2. So this is a straight line. As you can see, this is a straight line and this is a node and a node. And in my previous video I briefed on the nodes. That is the junction of a node is a part that current meets or divides. So we are going to talk about the short circuit and we are on it. So short circuit, in theoretically, it is zero resistance. So current move through circuit or move through circuit with least resistance. That's, they don't want resistance, so they are moving through it with a least resistance theoretically. So now, for example, this is an example that I chose for us to do, and this is a course under electrical engineering. That is EE151 in the university. So I hope you watch this video and share it with your friend, please, and don't forget to subscribe to my channel. So with this is a diagram. This is a diagram of a electrical circuit. So this is the cell. So now we are going to identify which resistance has been short circuited. So when you look at this diagram, you know that, as I said, that a short circuit is a theoretically and a zero resistance. So current move through resistance. Yes, like they move through least resistance. That's zero resistance connection. So now, if the current moves from here now and it moves here, so the current from this source, it divides like this, and one also move up like this. So normally it moves from the negative terminal to the positive terminal. Sorry, so this one, let me raise it. So it has been erased very nicely. Sorry for that. So now the electric current moves from this side. When it gets to these nodes, it divides and it divides. But when it gets to this junction or this node, you know that this and this, from this side to this side, is a short circuit. Because for example, when you are moving to, maybe you have a place that you are going and you have a short way of going to that place and a long way. Normally, as a human being, normally you want short way, right? So you will normally take the short way to the place. That's how current also do their thing. So if it's moving, it cannot go and pass here. This resistance or this resistance here and this I think not in use, because the current will not go and pass here, but it's rather pass to this one. You just pass here. I think this one, it will pass here. So the current will move from, I think, this side. It will move from this side and also pass here, and this also will join and go. So with this, if they ask you to find the total resistance of this, what you need to do is these two resistors have been short circuited. Let's read. 4 ohm and 5 ohm resistors are short circuited because current flow through part of theoretically zero resistance. So as I said, so it's not even bother to pass it because it wants a short way where there's less resistance. Because if you are moving through a door, for example, there are 2 doors and most people are passing through one door, there's a resistance there. So therefore you will take another route, which is the another door so that you can get least resistance. That's how current they do their thing. So let's check. For us to find the total resistor or the resistance, you know that this has been short circuited, so they are not part. So this and this are in parallel, and that's in parallel. For my previous video, I taught you how to calculate for the parallel resistor. So you do that, and the correct way, you're going to get 2.2 ohms as you do the correct way. Yes. So with this is the whole idea about the short circuited. Like, to be short circuited means that you have a zero resistance. You see, the current will not go and pass it because it has a pathway which has less resistance to reach the positive terminal. So let's take another question, which is, this question was EE152. Is it EE151? First semester exams in I think applied electricity in Kwame University of Science and Technology. So let's try this. So with this, they're asking us to find the total current. Now, with the total current, before you do it, you need to identify the short circuit. So if current is passing through here, right? Please, I want you to do this work and provide on your comment section. Try your hands on this for 5 minutes. Let me do it for time. Let me give you only 1 minute. Try your hands on this and let's see whether you can get the answer. So please comment your answer and let me see. Yeah. So as I'm saying that, subscribe to my YouTube channel for more videos. That's my YouTube channel is about information technology, basic mechanics, principle of material engineering, hackway. This is about tutorial. Like, I'm a tutorial king, right? So everything about tutorials, anything I want to show you, editing, everything, I'm in. So with this, I now know that you've done, right? I hope you are done. So comment, let me see your, so I will reply to your answer. So now let's see, verify our answer. So when current move from the negative terminal, will it divide? Well, let's see. For us to identify, let's identify the short circuit. You see this, the current, this is a resistance and this also is a resistor, right? You have a some 4 ohm resistor here and 2 ohm resistor. The current will not pass through any of this because it doesn't want stress. No stress. Yes, I don't want stress. The current is like, I don't want stress. So when the current pass here, what you're going to do is going to pass through here and come back to its section. So it means that this and this has been short circuited because it's mass. The current flow through part with least or theoretically zero resistance, right? So it needs to pass through here and it will not pass through this resistor nor this. So it will just pass through this. So for us to find the current, that's the current using Ohm's law. That is, total resistance is 3 ohms. Yes, because it doesn't pass here and pass here. So we have the total resistance to be 3 ohms. So we finding it from Ohm's law. You know that voltage or the potential difference is equal to current times resistance. Now, as far as we have the voltage and the resistance, we find the current. So that will be 5 volts over 3 ohms, and that's the current is 1.67. That's 1.66, but with rounding of numbers, that's 1.67 ampere. Yes. So this is how short circuited is. Thank you very much for watching this video. Please subscribe to Prof1YT YouTube channel and for more exciting videos. Thank you very much.